Alright, welcome to a short presentation of the periodic table of the elements. The periodic table was created by Mendeleev to try to figure out a way to organize the elements. He arranged them by reactivity and atomic mass. Henry Moseley later arranged them by atomic number, fixing problems with Mendeleev's table. Families were incorporated, which are the vertical groups on the table that showed that the elements have the same number of valence electrons and react in a similar fashion. The horizontal rows, or the periods on the table, show that the elements are in the same energy level. The first group that we're covering are the alkaline metals. They are organized for being the first group in the S block. They have one valence electron. Physical properties include being shiny, soft metals that are malleable, ductile, and are good conductors of heat and electricity. Chemical properties include being highly reactive and standard temperatures and pressures, having one electron in the outermost level, and they are all reactive with water. Common elements include lithium, sodium, potassium, rubium, etc. Uses include being used in batteries, atomic clocks, sodium vapor lamps, etc. The second group that we're covering are the alkaline earth metals. Alkaline earth metals are defined by being the elements in group 2 of the periodic table with 2 valence electrons in the s orbital. Physical properties include being silver-colored, soft, low-density elements that have low melting and boiling points. Chemical properties include being highly reactive, reactive with water, not being able to be burned, and that they easily lose electrons. Common elements include beryllium, magnesium, and calcium. Uses for these elements include military weapons, electronics, and commercial application. This next group that we're covering are the transition metals. These are defined as the elements whose atoms are partially filled in the D subshell. Physical properties include that they are all metals and good conductors of electricity. They are hard, have high densities, also having high melting and boiling points. Chemical properties include being great catalysts, they are stable, they form compounds with variable oxidation states. The valence electrons are in the D block, and they form colored compounds. Common elements include copper, platinum, iron, and titanium. Uses include building materials, tools, vehicles, pipes, and cables. The next are the lanthanides. The lanthanides are rare earth elements found in the F block, specifically in the F4F row. Physical properties include being soft metals, metallic, high resistivity, and hardness increase across the series. Chemical properties include filling the 4f orbitals, and they have stable electronic configurations. Common elements include lanthanum, cerium, thulium, and thulium. They are used in hybrid cars as batteries and magnets, commercially used for car parts and conductors, and also the next ones are the actinides. These are also elements that are metallic chemical elements found in the F block, but these are found in the 5F. They are large. They have large atomic and Ronic radii. Physical properties include being silver in color, have high densities and plasticity. They are radioactive soft metals with the metallic texture and with metallic color, and high resistivity. They fill the 5F orbitals. They are highly toxic, exist in very oxidation states, and they readily oxidize and ignite highly radioactive. And they are highly radioactive. Oh, God. Common elements include uranium and neptunium. They are used in smoke detectors, gas mantles, nuclear weapons, fuels, and nuclear reactors. The next group are the metalloids. The metalloids are elements with properties between metals and nonmetals or a mixture. They are the diagonal in the P block. Physical classifications. They have a metallic appearance, but are brittle and are fair conductors of electricity. Chemical properties include being which that they readily form glass. They form alloys with metals. They have multiple metallic and non-metallic allotropic forms. They react with halogens to form compounds. Common elements include boron, silicon, germanium, and arsenic. Uses include in biological agents, catalysts, and flame retardants. Also, they are used in glasses. The next one are the next group is the nonmetals. They are defined as elements that lack in metallic attributes. The physical properties include being highly volatile or easily vaporized. They have low elasticity, are brittle, resist magnetivity, are good insulators of heat and electricity. Chemical properties include being able to gain electrons when reacting with metals. They combine with bases to form salts. They dissolve in water to form acids. Common elements include hydrogen, helium, and oxygen. Uses include charcoal, semiconductors, or oxide glass. They have the next group are the halogens. The halogens are defined as elements that produce salts when they react with metals. Physical properties include high boiling points. They exist in all three states of matter at standard temperature. Chemical properties include that they form acids when bonded. They form acids when bonded. They react with metals and hydrogen. Highly electromagnetic, and they have highly electromagnetic. Common elements include fluorine, chlorine, bromine, iodine, and acetone. Uses include flame retardants, disinfectants, some found in the body, inside tissues, and saliva. The last group that we're covering today are the noble gases. These are defined as the elements that are very low in chemical reactivity. Physical properties include very low melting and boiling points. They are all gases under standard conditions. Chemical properties include being unreactive except for in extreme conditions. The outermost layer is full with 8 electrons. They are odorless, non-flammable, and the common elements include helium, neon, argon, krypton, xenon, and radon. Uses are in light bulbs, breathing gases, lighting, and welding. This was the periodic table presentation, and I hope you learned something.